All right, fellow Algebra 2ers, here is a video key for your 2B.4 review. Number one, we're going to get a common denominator. So this side needs an x plus 1. This side needs an x minus 1. Get rid of this number here so it's not in the way, but this is number 1. And so I'm going to multiply this side on top and bottom by x plus 1. And multiply the other side by x minus 1. And so you don't need to FOIL the denominator. Now that our denominators are the same, we can set our numerators equal to each other. I'm going to distribute at the same time, so 6 times both of these gives me 6x plus 6. And on the green side, also distribute the 9, giving me 9x minus 9. Again, that's just doing 9 times both of those. And now get everything on the same side, or x is on one side, the number is on the other. So if you want to subtract 9x or subtract 6x, that's up to you. I like to keep my x's positive, so I'm going to subtract 6x, giving me 3x on this side. And then I'm going to add this 9 over to this side, giving me 15. Divide both sides by 3, and you get x equals 5. Check for extraneous, but this one should work. Again, I think the only way that you get extraneous is if you plug in 5 and you get 0 either there or there. So we're not getting 0 on the bottom, so we're good. Number 2, you got to double bubble first. Number 1, we didn't have to double bubble because there were no quadratics on the bottom. So double bubble, this is a difference of squares. So that double bubbles into x minus 1 times x plus 1. Okay, so that double bubbles like that. So now we're not looking at this anymore. And so this has a factor of x plus 1 that this one doesn't. So let's give that an x plus 1 on top and bottom. Like so. And we got to do that to this side also. So we need to multiply that whole thing by x plus 1 and x minus 1. It's missing both factors on top and bottom. So we're multiplying top and bottom by that. So that gives us a common denominator of x plus 1 times x minus 1 everywhere. So now we just need this, FOIL that, or distribute, plus this, and then we got to FOIL over here, so it's going to equal that. So taking the purple, we get 2x squared plus 2x. The black stays the same, it's just plus x minus 5. Remember, if this were a minus sign, you got to distribute the minus. It would make the x negative, and it would make the 5 positive. And then that equals the green, and the green distributed is just what we started with because that's how we found it. So you can FOIL if you don't think about that, or just know that it's going to be x squared minus 1. So you get that. And now we have a quadratic, so I'm going to move both of these to this side. Subtract x squared from the green x squared from the purple, giving us x squared. Combine the x's right here to get plus 3x. And then add the green 1. So add this to both sides, giving us minus 4 equals 0. Now we can double bubble into x minus 4, nope, x plus 4 times x minus 1 equals 0. And that gives us x equals negative 4 or positive 1. But you can't plug in positive 1 right here because you would get 0 on the bottom. So therefore, we're going to label that one as being extraneous. And the word will be written on the test. I know people don't know how to spell that word very easily, but it'll be written on there. There it is. And even if you misspell it still, I don't really care actually. So, all right, so there we go for number 2. Now, again, ignore the directions. We should be checking for extraneous solutions on all of these. So forget that that's even there. All right, number 3, we got a double bubble again to start with. So we're getting rid of this. And we're double bubbling that into x minus 6 times x minus 2. And that's nice because here's x minus 6 and x minus 2 on the other side. So all we have to do is multiply the first one by x minus 6 on top and bottom. And the second one by x minus 2 on top and bottom. Okay, so now that all of our denominators are the same. So the black just becomes 4. Equals, distribute the x for the pink, giving us x squared minus 6x. and distribute the 1, which does nothing, to the blue, so it's just plus x minus 2. Once again, if that's a minus sign, it would be minus x plus 2. You gotta switch both of those because you gotta distribute the negative. Once again, we have a quadratic. So I'm going to set it equal to 0. So we have 0 equals x squared. Combine these to get negative 5x. And I subtract the black 4. Combine it with the blue 2 to get minus 6. Now this is double bubbleable into x minus 6 times x plus 1. And so you get x equals negative 1 and positive 6. And then positive 6 is extraneous because you can't plug in 6 right here or you'll get 0 on the bottom. So once again, just label this as being extraneous. And call it a day. All right. So it's a lot of the same stuff over and over. You know, problems can look a little different here and there, but as far as the algebra. All right, so number 4 now, getting rid of that 4. We need x plus 3 over here because of this one. We need x minus 3 over here because of this one. And then number 2 needs both. So let's multiply this by x plus 3 on top and bottom. Multiply the right side by x minus 3 on top and bottom. And then the 2 needs both of those. So we're going to multiply by x plus 3 times x minus 3 on top and bottom. Remember, 2 has a bottom of 1. So over 1 times x plus 3 times x minus 3. All right, so the purple, now our denominators are all the same. So we can ignore them essentially. The purple, I'm going to FOIL. So it's this times this, this times this, that times that, combine those, and that times that. So it's 2x squared, and then it's going to be minus 3x plus 6x, so plus 3x when you combine those, minus 9. If you're not sure where that came from, just show all the terms. It's this times, sorry, these two multiplied together and these two multiplied together combined. So we get that. And then I'll do the orange in 2 steps. I'm going to leave the net minus 2, distribute or FOIL those, and you get x squared minus 9. And then that equals the blue side, which just distribute the 12 to get 12x minus 36. And now distribute the orange to get negative 2x squared plus 18 equals, everything else is the same, 12x minus 36. We'll just duplicate this. All right, and now set it equal to 0. What's nice about this one is, look, you have 2x squared and negative 2x squared. So when you combine those, they're just gone. So those are gone. I'm going to subtract 12x to this side. You can do it the other way around if you want. But in any case, that gives me negative 9x. Then I have to add this to this side. Or actually, since we don't have a quadratic, I'm going to move the 9 over here, giving us negative 27. And then divide both sides by negative 9, giving us x equals 3. But x equals 3 is actually extraneous, which means this problem has no solution because the only solution we found is extraneous. Okay. Again, it's an extraneous solution because you can't plug in 3 right here or you'll get 0 on the bottom. All right, number 5. Again, you got a factor. This is a GCF. So they both have x, so take out an x, giving us x minus 2. So now we're ignoring this. Okay, and this has x and x minus 2. This has just x. This has just x minus 2. So this one needs x minus 2. So give it x minus 2 by multiplying top and bottom. This one needs just the x. So multiply top and bottom of this by x. And now we can ignore the denominator since they're all the same. And it's 10x plus this equals that. So we have 10x from the black. From the blue, distribute the 4. So you get 4x minus 8. And then equals the orange, which is just 5x. So probably the easiest thing is you have 14x, subtract 14x to the other side, and you get negative 8 equals negative 9x. Divide both sides by negative 9, you get x equals 8/9. And that one works. That one's not extraneous because you don't get 0 on the bottom if you plug it in. All right, number 6 is similar in terms of this has a GCF of x. So that becomes x times x plus 3. Very similar to the last problem because this needs x plus 3. This needs both, so we have 3 things going on over here. So that complicates it a little bit because there's just more to do, but it's the same stuff. So multiply by this by x on top and bottom. This one by x plus 3 on top and bottom. The 4 needs to get multiplied by x and x plus 3. So x and x plus 3. So this is like a 4x when I distribute it. Actually, it's going to be a negative 4x when I distribute it. And the 18 needs nothing, so that stays the same because it already has the whole denominator. So now we take the orange here, and you get 2x squared from the top because of this x times x. Oops. Because of that x times x. Distribute the 5 in the blue, giving us plus 5x plus 15. Distribute negative 4x to both of these. So it's minus 4x squared minus 12x, and then equals 18. Okay, now we have a quadratic, so we got to set it equal to 0. I'm going to move the 18 over and just combine like terms over here. So we have negative 2x squared. Something weird will happen on this one. I'll show you in a second. Negative 2x squared, combine the x's, 5 and negative 12 is negative 7, minus 7x, and then you got to move this over here to get minus 3 by subtracting 18. So since we have a negative 2x squared, it's easier to factor when that's positive probably for most of us. So you can just switch the signs of everything. It's basically dividing both sides by negative 1, but that doesn't change the 0. So you can just make this 2x squared plus 7x plus 3 equals 0. And now we double bubble it, and you get 2x and x. And we're going to have, let's see, plus 3 there and plus 1 there. Because that's 6x plus x gives me 7x. And so from the first bubble, you get x equals negative 1/2. And from the second one, we get x equals negative 3. X equals negative 3 is extraneous because you can't plug it in for the x plus 3 bubble. So we'll label it as being extraneous. And call it a day. All right. There we go. All right, number 7, we start with a quadratic down here. So double bubble that into x minus 3 times x minus 2. So we don't need that anymore. And then this needs an x minus 2, this needs an x minus 3. So hopefully you're starting to pick up on how these problems are all very similar to one another. We're really doing the same thing pretty much every time, just with different numbers. Okay, so we do that. And then the black side, so all the denominators are now the same. The black side just stays 5x squared because we don't have to do anything to that side. Equals the purple, which is just x minus 2 because it's distributed 1, that does nothing. And then over here, distribute the negative 3. So the green becomes minus 3x plus 9. Be careful with that. That's one of the more common mistakes people make. All right, I was just double checking real quick. And now we have a quadratic again, so let's move all the purple and green stuff to this side. We can combine these first to get negative 2x and then add 2x. So it's 5x squared plus 2x, and then combine these to get 7, but then subtract 7 to move it to the other side equals 0. And is this double bubbleable? We have 5x and x equals 0. Looks like we have something that's not double bubbleable. So either I made a mistake somewhere, negative 3x plus 9 minus 2. I don't see a mistake. So come back and check the handwritten key. I don't want to waste time on the video trying to check for a mistake, but I'll double check this one to make sure everything's fine. But there's nothing I can put here. That would be 1, would give me 5. Oh no, this is right, sorry. If I put positive or -1 here and positive 7 here. So now I get -5x plus 7x is 2x. So this is correct. And now you can find x equals -7/5 and x equals 1. And neither are extraneous. So this one actually has 2 solutions. And again, neither are extraneous because you can plug them in to the bottom without issue. You don't get 0 on the bottom. Okay, and then finally the word problem. Okay, so we're going to use distance equals rate times time, which can be manipulated to be time equals distance divided by rate. And that's what we need in this one because we know that the 2 boats are traveling for the same amount of time. So we need to set up 2 different things here. We have with current. So with the current, our distance, I'll call it D1, is equal to 95. And our rate, I'll just call it R1, is equal to 16 plus the rate of the current, which is what we're trying to find. And then against the current, which remember sometimes this is called upstream, this is called downstream. But against the current, we have a distance, we'll call it D2, of 65 miles and a rate of 16 minus the rate of the water. And so all we're going to set up is D over R equals D over R for the purple and the green because they both equal the same time. If they equal the same time, they equal each other. So distance over rate equals distance over rate, 16 minus R. And now we can solve this like we've been solving all the other ones. This one needs a 16 minus R on bottom. 16 minus R. This one needs a 16 plus R to get a common denominator. 16 plus R. All right, and now we can just set this equal to this because our denominators are the same. So we distribute. So I'm doing 95 times 16. Just getting a calculator out real quick. Although I know that 95 times 16 is actually 1,520. So this turns into 1,520 minus 95R equals 65 times 16. That one I do need to do on a calculator. And that's 1,040. So we'll keep that green, I guess. 1,040 plus 65R. And now we can just get R by itself. So subtract 1,040. Show the work on this one. Subtract 1,040. And I'm going to add 95R at the same time to both sides. So 1,520 minus 1,040 is 480. So you get 480 on this side is equal to, we're just doing 65 plus 95, which is 140R. Whoops. And then divide both sides by 140. So divide by 140 on both sides. Giving us R is approximately 3.429 miles per hour. Okay, that's a weird number. I couldn't remember what this answer was off the top of my head without doing it. So check back to the handwritten key. I'm going to double check this one after the video, but double check the handwritten key. Make sure that that's the right answer and that I didn't make a mistake. All right, there you go. Good luck on your test.